All right, so I'm going to be going over the Exam 4 review. Exam 4 covers sections 6.1 and 6.1 through 6.7. The first question on the test is going to be pretty simple if you think about it. Matching the polynomial with its factorization or vice versa. So you can kind of think of this more as an exercise in multiplying and then matching the polynomial, because 14x minus 3 times 2x plus 5, 14x times 2x is 28x squared, and then the L in FOIL gives us minus 15. So when you look over there, there's this 28x squared and there's 28x squared, but there's only two of them, so it's either 5 or 7, 50-50 shot. But then we check the O in FOIL, which is 5 times 14, which is 90x, minus 6x. 70x minus 6x, which is 64x. So we see that it's V. Now, by process of elimination, this one also gives us 28x squared plus 35x minus 12x minus 15, and 35 minus 12 is 23. So that one is 7. Now the opposite of m plus 20 times m minus 20, that's the opposite of m plus 20 times m minus 20 is m squared minus 20m plus 20m is 0 minus 400. And we distribute the negative across, we get negative m squared plus 400. The other m up there is this one, that's m squared minus 40m plus 10m, which is minus 30m minus 400. So now we're looking for m squared minus 30m minus 400, which is 6. Now we're on to this one that has r's on it. That's 16r squared. And r times negative 9 is negative 9r. So 16r squared minus 9r is 2. In letter G, we have 16r squared plus 12r minus 12r, which is 0, minus 9. Now we're looking for 16r squared minus 9. There's one left over and one that we haven't used, so it's got to be the answer. But remember, t minus 2 times t plus 2 is t squared minus 4. And t minus 2 times t plus 2 is t squared minus 4. When we multiply all that out, we get t to the 4th minus 4t squared, which is minus 8t squared. And negative 4 times negative 4 is positive 16, giving us number 1 for the answer. Okay, those should be pretty easy if you're careful. And now the open-ended responses. Completely factoring. Completely factor. The number one thing we always look for is the greatest common factor, and in this case, the GCF is 5ab. I always use the rule of thumb. If the first term's negative, I factor it out. When I take a negative 5ab off of negative 5ab squared, that's going to leave me with ab. When I take a negative 5 off of a positive 10, it leaves me with minus 2. I took 1a off of 2a, so it leaves me with an a, and 1b off of a b, so the b's are all gone. Finally, I take a negative 5 off of negative 15, it leaves me with a plus 3. I took ab off of ab, so it's now gone. Okay, and the remaining trinomial b minus 2a plus 3, there's nothing I can do to factor that. And so that's our final answer. Number 3, the common factor of x minus 2 is staring at us. Since there are two of them there, they come off as one of them, x minus 2. And that leaves me with 4 minus x in front. Number 4 has 4 terms. When we have 4 terms, we group the first 2 together and factor out their greatest common factor. From the second pair, I can take out a negative x, and that's going to leave me with y minus 3. I've produced the same binomial, y minus 3, so I factor it off to the right-hand side, and I'm left with 2 minus x. Number 5 is a difference of 2 perfect squares. The two terms that are being squared are 2x and an 11. So when we factor that, we recover our two terms, 2x and 11. We add them, and then we subtract them. Number 6 is another binomial, 2 terms. And when we have 2 terms, we try to factor it using one of our formulas. But first, we look for the GCF. And that leaves me with x to the 4th minus 81. When you have binomials, as in number 5, you look to see, do you have perfect squares or cubes? In this case, we have perfect squares. So this x to the 4th is the square of x squared. 81 is the square of 9. X squared and 9, we add those, and we subtract those. But remember, you need to check your factors to see if they are completely factored. X squared plus 9 is a sum of 2 squares, and that's always irreducible. But x squared minus 9 is a difference of squares. It reduces as x minus 3 and x plus 3. So remember, difference of squares factors, but sum of perfect squares is not factorable, is prime. So for this one, you would just say, it is prime. I can't factor that any further. Okay, then we look at a couple of trinomials. In number 9, if the a is 1, the AC method turns into negative 12. That adds to negative 4. The pair of numbers that give me negative 12 that add to 4 are negative 6 and 2. When the leading coefficient is 1, it's like magic. All we do is put those numbers back in their respective places and get x minus 6, x plus 2. Now, you're always welcome to write it in the other order as well. X plus 2 times x minus 6. Either one is okay. In number 8, in this case, AC is 3 times negative 5, which is negative 15, that adds to negative 14. Those numbers that give me negative 15 and negative 14 are negative 15 and 1. But it's not so easy anymore like the last example, last exercise. This time we replace the negative 14x with negative 15x plus x. We factor out the 3x from both of those, and we're left with x minus 5. This is an x minus 5. Now we have a common binomial. We factor it off to the right-hand side, and we're left with 3x plus 1. Three x plus 1 times x minus 5. Number 10, the numbers are a little bigger this time. 8 times 6 is 48. But then I realize or recognize that I can take a 2 out of each one of those terms, giving me 4a squared. Chastity, very good question. Your question will be answered as we progress into solving the equations, that's where you will say x is 1/3 or x is 3 or x is 5. But when the problem says only to factor it, you leave it in factored form and not solving it. It's very tempting to do what you did, and a lot of people do that. But no, you can't say x plus 1/3 yet. You have to say 3x plus 1. 3x plus 1 times x minus 5. But I'm so glad you asked that because you just saved yourself a lot of points in the test. I mark off a lot of points for people that solve when they're supposed to just factor. Okay, back to number 10. GCF of 2, which will leave us with 4a squared plus 8a plus 3. So I factor that one using the AC method, which is 4 times 3, which is 12. That adds to 8. We got 6 times 2 is 12, and 6 plus 2, which is 8. All right, so from our first pair, 4a squared and 6a, we take out a 2a. And that leaves us with 2a plus 3. My second piece is a 2a plus 3. So from these pieces, we factor out the 2a plus 3 to the right-hand side. Leaves us with 2a plus 1 and the GCF of 2 out in front. Number 11, 16x squared plus 24xy plus 9y squared. Take out 3. From number 10, I can't take out a 3. Oh, okay, you're ahead of me. All right. 16 is not divisible by 3. So I can't factor out anything from those 3. So I'm tempted to do the AC method, 16 times 9, which is 144. That adds to 24. We would use 12 times 12. Well, when anytime you use the same number twice, that means that this is a perfect square. That's a perfect square. And so remember what we would do is we'd say recover the pieces, which is 3y and 4x. And if our middle term is twice those two pieces, which it is, then that means that this is a perfect square. And it is the square of 4x plus 3y. Number 12, another binomial. It's not a cube or square. So all we see is that there's a common factor of x to the 6th on both of those. And so we factor it out and get x to the 6th times x plus 1. And that's all you can do with that. And then number 13 is a trinomial. And the AC method says product of two numbers, it's 1 that adds to 1. To get 1 is 1 times 1, but 1 plus 1 is 2. -1 times -1 is +1. Add those and I get -2. Neither of those is going to give us 1. And so this is a prime polynomial. Nothing we can do to factor that. All right, number 14, we got 4 terms. We have 4 terms there. So the first pair, we factor out an x. Leaves us with y plus 4. For my second pair, I factored a -2. and it leaves me with y plus 4. Now I factor out the y plus 4 to the right-hand side, and that will leave me with x minus 2. X minus 2 times y plus 4. All right, number 15 is a binomial. We have an x cubed and a 64. That looks like the cube of x and the cube of 4. So this one you have to memorize that long formula to get it factored. I would always say something like recover your two terms, x and 4. And then I would say square the first, take the product of the two, and square the second. Then to make sure that everything cancels out in the middle to only end up with a binomial, we said use the same sign, opposite sign, and always positive. SOAP. So then that means the first factor is x plus 4. Then we get x squared minus 4x plus 16. Number 16, the first term is a 25x squared. That looks like a perfect square, but the last term, 6, is not. So we just have to use AC method. 25 times 6 is 150. That adds to 25. 10 times 15 is 150, and 10 plus 15 is 25. So we replace 25xy with 10xy plus 15xy plus 6y squared. From the first pair, we factor out a 5x, and that'll leave us with 5x plus 2y. From our second pair, we take out a 3y, and that'll leave us with 5x plus 2y. Now we see the common binomial of 5x plus 2y. We factor it off to the right-hand side, and that leaves us with 5x plus 3y in front. Seventeen's a binomial. We got some squares and cubes in there, so that means the GCF needs to come out first, which is 9x. When I take 9x off of a 9x cubed, I'm left with x squared minus 1. X squared minus 1 is x minus 1 and x plus 1. All right, so as Chastity brought up earlier, there's a difference between factoring and solving. Factoring, we leave it at these multiplications, 9x, x minus 1, x plus 1. But when we solve equations, that's when we get to set each factor equal to 0. We use the zero product property to do that. That means the first step in solving any quadratic equation is to get 0 on one side. Once we do that, we then factor the polynomial. X minus 12 and x plus 1. Now the zero product property takes over. The first factor, x minus 12, is 0. The second factor, x plus 1, is 0. This gives me x equals 12. This gives me x equals negative 1. This is when we get to say x equals, because it says solve instead of factoring. Number 19, we have to distribute the 2p across, which gives me 2p squared plus 4p. Now we get 0 on one side. We're going to subtract 2p squared and subtract 4p. From my polynomial, I factor off a 2p. That leaves me with p squared minus p minus 2. Now we factor the p squared minus p minus 2 as p minus 2 and p plus 1. Now we set each factor equal to 0. 2p equals 0, p minus 2 is 0, and p plus 1 is 0. If 2p is 0, we divide by 2, and we get p equals 0. You add 2 to both sides, and we get p equals 2. Subtract 1 from both sides, and get p equals negative 1. For some reason, a lot of people forget the p equals 0. And I can say something like, anytime all your terms in your equation have a p in it, then you get p equals 0. In number 20, we already have 0 on one side, so we factor. We like the grouping method, so we go AC, which is negative 18, to get negative 7. Those two numbers are negative 9 and positive 2. So we replace the negative 7x with negative 9x plus 2x. Now we factor by grouping. And we see a common factor of 2x minus 3, so we pull it out to the right-hand side, and that leaves us with 3x plus 1. Now we set our factors equal to 0 and solve. 3x plus 1 equals 0, or 2x minus 3 equals 0. If I have 3x plus 1 equal to 0, I subtract 1 from both sides and divide by 3. If I have 2x minus 3 equal to 0, I add 3 to both sides and divide by 2. Number 21, we've got y plus 3 times y plus 3 equals 16. We don't have 0 on the right side, so we're going to have to subtract it. But before we do that, we're going to have to FOIL out the y plus 3 times y plus 3. It's y squared plus 3y plus 3y is 6y plus 9 equals 16. Subtract 16 from both sides, and I get y squared plus 6y. 9 minus 16 is negative 7. So then we factor y plus 7 and y minus 1 equals 0. Setting those two factors equal to 0, y plus 7 equals 0, or y minus 1 equals 0, tells us that y equals negative 7 and y equals 1. Number 22, just like I said in number 19, when each term has a p on it, one of the solutions is going to be 0. When each term has an x on it, one of the solutions is going to be 0. We factor out the x and get x plus 5. So we set x equal to 0, and we set x plus 5 equal to 0. First one says x equals 0, and the second one says x equals negative 5. Number 23, we need to get 0 on one side, so we subtract 22x from both sides, and then we add 7 to both sides. We use the AC method. 3 times 7 is 21. That adds to negative 22. Negative 1 times negative 21 is 21, and negative 1 minus 21 is negative 22. Okay, so we replace the negative 22x with negative x minus 21x. So we factor out an x from the first pair, leaves us with 3x minus 1. We factor out a negative 3 from the, we factor out a negative 7 from the second pair, which leaves us with 3x minus 1. Now the common factor of 3x minus 1 can be brought out to the right-hand side, which leaves us with x minus 7. Setting each factor equal to 0, x minus 7 is 0, or 3x minus 1 is 0. X minus 7, 0 gives us x equal to 7. 3x minus 1 equals 0 gives us 3x equals 1, or x equals 1/3. All right, so there's the factoring portion of it, and then we have a couple of application problems. The first one is about diving from a board. When you dive from a board that's 32 feet tall, there's the water. You dive off the board and into the water. I want to know how long it will take us to hit the water. So if you think about this, this is the h-axis, or the height of the diver, t seconds after the diver dives off the board. If we want to know when it hits the water, then that's when h is equal to 0. Hits the water, we set h equal to 0, and we solve. 0 equals negative 16t squared plus 16t plus 32. So you factor a negative 16 from all three terms. It leaves me with t squared minus t minus 2 equals 0. So we factor, and we get t minus 2 and t plus 1 equals 0. And now we set the factors equal to 0. But remember, negative 16 is never equal to 0. And in fact, since it's not, we can just divide it. Remember, it's okay to divide that because it's a number, but you can't divide by variables. Now the two factors are t minus 2, and that's 0, or t plus 1 is 0. The first one says t equals 2. Second one says negative 1. It's only after 2 seconds will the diver hit the water. The negative 1 just comes from the fact that that parabola would have intersected the t-axis or x-axis over at negative 1. So the only one that makes sense here is the 2 seconds. Number 25, I've warned you about this problem before. We have a rectangle. And the length of the rectangle is 3 feet longer than its width. So if that's its width, its length is 3 feet longer than it. But we know that the area is 40 square feet. That's the square feet that tells me its area. And that's its length times its width. So if we take its length of 3 plus w and multiply by its width, that'll give us an area of 40 square feet. So there's the equation to solve. We distribute the w across and we get 3w plus w squared equals 40. Subtracting 40 from both sides, that'll leave us with a w squared plus 3w minus 40 equals 0. And so now we use the AC method. Product of two numbers that's negative 40, that adds to 3. 8 and negative 5 are the numbers. 8 times negative 5 is negative 40, and 8 plus negative 5 is 3. When the leading coefficients are 1, all you have to do is put them into their place, w plus 8, w minus 5, and now we set those two equal to 0. W plus 8 equals 0 says w is negative 8. W minus 5 equals 0 says w equals 5. Remember, negative widths don't mean anything, so we cross those ones out. But the width of 5 feet means something, and the length of 3 plus w is 8 feet. So our dimensions are 8 feet by 5 feet. And 8 times 5 is 40. All right, the last question on here is an extension of the problem that you had on your last exam. I gave you a rectangle that looks something like this and asked you to tell me what the area of this rectangle is. Now I'm wanting you to solve for x and then find the dimensions of the rectangle. So we first see that the area of this rectangle is 72 square feet. And we also know that the area of this rectangle is the length times the width. The length of this rectangle is x plus 10, and the width of it is x plus 4. Or it really doesn't matter which one's the length or which one's the width. So the area is the length times width, which is x plus 10, and the width is x plus 4. And that gives us 72. To solve that, we have to FOIL out the right-hand side, giving us x squared plus 4x plus 10x, which is 14x. 10 times 4, which is 40. So we subtract 72 from both sides. 40 minus 72 is negative 32. Product of two numbers, it's negative 32. That adds to 14 is going to be positive 16 and negative 2. So those are the numbers that factor it, x plus 16 and x minus 2. And since we want to know when that product is 0, we use the zero product property and set each factor equal to 0. The first one gives us negative 16. The second one gives us x is equal to 2. But remember, negative dimensions don't mean anything to us, so we just get x equal to 2. So the dimensions of my rectangle then are x plus 10 by x plus 4. 2 plus 10 is 12. 2 plus 4 is 6. 12 feet by 6 feet gives me 72 square feet. Now, of course, there was another way to find the area of this rectangle. We just say that this box is x by x, which is x squared. This box is 10x. This box is 4 times 10, which is 40. And this box here is 4 times x. There's the x squared. 4x plus 10x is 14x and 40. That was another way to figure out the area of the rectangle in terms of x. All right, so that's all the problems that you'll see on the exam this week. And you do have the options of taking it tomorrow or Wednesday. And so now I'll ask you guys for any questions.